Alright guys, so this is going to be our last section for chapter 1, so we're going to go ahead and get moving on this. We're talking about patterns, equations, and graphs. So you want to pause and copy this down. A solution of an equation with two variables, x and y, is any ordered pair of x and y that makes the equation true. This is a little bit different than the stuff that we were looking at before. Now we're talking about if we have two variables. So for instance, y equals 3x plus 4. Well, there's different ordered pairs that we could plug in for x and plug in for y that's going to make that true. Inductive reasoning is the process of reaching a conclusion based on an observed pattern. So a really simple example would be 2, 4, 6. The next one in that pattern you would expect to be 8. Now the reason it's called inductive as opposed to deductive is that you cannot prove for certain that this is going to actually be an 8, but all of the evidence, it's increasing by 2, all of the evidence points to that being the case. But it really could have been any number, so you can't prove with facts that that's going to be what the case is. You could just prove by, well, if this were to continue, this is what we suspect it will be. So we could use inductive reasoning to predict values, but one of the things that you need to know with a prediction is that predictions don't always come true. It's just that, a prediction. So every now and again I want to throw these pop quizzes in for you on these online videos. So your pop quiz is this today. Oh, you failed it. I'll leave you to think about that one for a moment. Okay, so identifying solutions of a two-variable equation, it says, is 310 a solution of the equation y equals 4x? Well, you simply just substitute these two values in. Make sure that you are putting them in for the right value. So instead of writing y, I write 10, and instead of writing x, I write 3. Quick refresher, remember, it's x, y in an ordered pair. It's confusing because if you look at this equation right here, oftentimes equations are written with the y first, so y equals then x. Be careful because ordered pairs are written like this, x, y. So here I have 10 equals 12. That is not a true statement, so we'd say no with an exclamation point. Alright, so here, using in a table, an equation, and a graph, it says both Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So the first way we're going to do is with a table. So I'm going to have K is for Kim and C is for Carrie. It doesn't have to be a very elaborate table or graph. So here's my table and we'll just start right here. Okay, so Carrie and her sister Kim were born on October 25th, but Kim was born 2 years before Carrie. So Kim is the older child. So when Kim was born, she was 0 years old, and Carrie was not existent. We'll just put a dash there. When Kim was 1, Carrie was still not born. And then when Kim was 2, Carrie is now 0. And then I could continue this on. I don't really have a lot of room on here, but we'll do one more at least. When Kim was 3, Carrie was 1. Okay, so that's all based on this. So here's one way to represent this graph, or this situation, through a table. An equation, you could write this a couple different ways. To find Carrie's age, so Carrie's age is going to equal, we'll take a look at a couple of these. Carrie is 2 years younger than Kim, so I take Kim's age and I subtract 2. Or if I want to write Kim's age, I would take Carrie's age and add 2 to it. So whatever this is, I add 2 and that gives me Kim. So that would be written like this. If I wanted to do this as a chart, or a graph, I could do this in a couple different ways. I'm going to call this one Kim and this one Carrie, and we'll say this is 0, and then 1, 2, 3, and we'll just go to 4. We don't need a big long one to get the point across. So 1, 2, 3, and 4. So there are my things, and I just go and I start plotting these. So first of all, when Kim this is Kim. When Kim was born, she's starting here, but Carrie was nowhere, right? Carrie didn't exist yet. So really, if I'm doing this graph, I have to start right here when Kim was 2 and Carrie was 0, all right? And then I go up to the next one when Kim would be 3 and Carrie's 1. And then 4 and 2. And I kind of run out, but this, you can see how this kind of creates a pattern where that would extend going on forever. So that would be the graph that represents the relationship between their two ages. And please excuse my not straight lines. All right, so you go ahead and take a look at that one and try. You want to make a table, an equation, and a graph. All right, so for this one we have two different people. We have Will and we have Megan, so I'll just make a quick chart. Now on this one, you could do this different ways, but I'm going to start with the 6 laps that Will runs before Megan. So when he's ran 6, Megan's ran 0, 7, 1, 8, 2, and you can continue that on. In equation, you'd have a couple of them. Megan is going to be whatever Will ran minus 6. Will is going to be whatever Megan ran plus 6. And then a graph of this look something like this, and it doesn't matter where you put Will or Megan, just as long as you make it clear. So I have 1, 2, 3, 4, 5, 6. This is 0, and then Megan 1, 2, 3, 4, 5. We'll go up to 10 on both of these. So there's 10. So Megan joins him, so when he runs 6 or 7 laps, Megan's ran 1. And then we go to here, 8 and 2, and 9 and 3, and then eventually 10 and 4. And I'm doing my best to line those up. If you're using graph paper, this should look nice and clear. But hopefully you had something that looks like this. All right, extending a pattern. It says the table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern. What is the total number of tiles in a figure with 8 blue tiles? So there's a couple ways you could look at this, but it says the number of blue tiles right here is related to this. And hopefully, if you were in 3rd grade and you learned your multiplication facts, you noticed the pattern here. All of these are 9 times this value. All right, so 3 times 9 is 27, 4, and so on. So if you extend that pattern, you could draw this out and do 6 and 7 to get to it. But ideally, you see that it's going to be 8 times 9, which is going to be 72 tiles. All right, that's what we would expect to happen. Oops. Let's see. Yep. All right, so that's it for today. Short video. That's nice. I will see you in class.